All right, cool. So I did a year abroad in Paris, and it was my final year, and I was in a school called Paris 8, which is just north of the city. It's in another city. It's like a suburb. Um, Coincidentally, that is where the basilica is. So there's all the tombs of all the kings and queens of France. And this is another building. They like architecture, but it's not. If you go inside, it's like an acoustic nightmare. Like it's just this cavernous, big space that is not useful. Anyway, so one day they told me, okay, classes are going. We're going to do registration day, and this is the day you have to go to school. You can't. There's no like internet. This is 15 years ago. A lot of things didn't have internet. And so I was used to UNO where we had this phone system where you'd like buy a big book called the catalog, and then you'd have the bulletin that would tell you like all the courses for that semester with all the codes for each session, and then you call on the phone and try to get, it would be busy a lot, and you'd have to like punch in these codes, and it'd say, oh no, that one's full, and it was a pain. And so for weeks, you would see people on the phone trying to get in. So I was very surprised when I went to the university, and I go there, and I'm like, where's registration? And they're like, oh, go up the steps, and you go, and it's a piece of paper on the wall. And there's like a list of classes, and then next to that, there's a sheet for every class, and you put your name down. Now, the thing is, that's like one department. So if you want a class in the history department, you have to go across the building and, write your name down where you're for that class. But then you can never see all the classes at the same time, right? So you're like, wait, I just signed up for a class at 8 o'clock. Like, I have to go change that one because I need this one. And it was a mess. It was total chaos. I was running around the building. Yeah.
Question: if a class was full, did you cross somebody's name off and write
You probably could. No, if a class was full on the first day, they would say, if you don't have a seat, you're not in the class. And so then people would, if you didn't get there early enough, that's another part of the system that's like not included in that paper. Anyway, so I was, studying computer science, and I remembered that this was something that we had actually studied. There's like a case study, a problem of how to code up a registration system in an object-oriented system. So my name is Eric Normand. This is my talk. Lies my object-oriented teacher told me. I have some disclaimers here because this is not an anti-object-oriented talk. Right? My education was object-oriented. We learned Java at school, and my teachers wrote the textbook on object-oriented design, and so it's not me bashing object-oriented. It's me bashing that education. Also, a lot of people ask me, how do I get out of my object-oriented mindset when I'm learning functional? Like, how do I develop that? And so this is some of the things that I had to get rid of in my head when I was converting to functional. So that's another thing. And so these are not just like only applicable in functional programming and object-oriented. They're totally applicable. Okay, so this is something I was taught. One day of class, the teacher said, "Look, this is how you model a problem in object-oriented. You take an English description, right? So, the description of students registering for a class. You underline the nouns, and those become your classes. And then you look for stuff like have, like you say, a student has multiple classes, right? Or can have multiple. So then that becomes like a relationship between the class and the student. And then you underline all the verbs, and those become the methods. Okay, let me see a show of hands. Who learned something like this in school?
Don't forget is.
Oh yeah, and is a, that's a hierarchy, like a subclass relationship. Wait, show me the hands again. Oh, about half. Okay, who learned it outside of school? It's not just about school. Yeah. Okay, cool. Cool.
Can you say what your first language was?
My first language,
So
or
when they taught you this, what was it?
this is Java.
Right, mine too.
Java. Okay, so let's just go through it just real quick. So this is a university that allows students to register for courses, da 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 da. So you underline the nouns. And look, there's three. There's university, student, and course. And some are repeated. And so then you draw a diagram like this. So you have a student. There was no UML. I would do it in total UML. But I didn't have the software. But so you have a student, and it's got some courses. You see there's like a arrow there, and then the university has students and courses, and you can call register, which is a verb, and it takes a course and it like adds it to this list, and it probably calls that one too to get back in there. Okay, and then just for fun, like George was mentioning, you say, well, a student is really a person, so we're going to do an is a, right? And then, well, you're going to have different departments, and like a history course might be different from a math course, so we're going to have these kinds of lines too. Okay, so it's lies. It's all lies. And it might not be the lies in the way you expect. The first one may shock you. Noun and verb, like that is like middle school level grammar that they're trying to say like their software is based on. Like a student, it's a noun, right? But it's also a verb. You just change the ending and it goes to, it's a study. Studious, it's an adjective. What do you do with an adjective? Does that become like a subclass? Like, it's crazy. Same for register. It's a verb, but it's also a noun, a register. Registration, it's a noun. Registry, the place where you register, it's a noun. So like, they're saying that you should design your software around the way you happen to describe your problem, like the words you happen to use. Okay, so it's just an easy takeaway. We need to look deeper than just the noun and verb and stuff. And there's more options for modeling than just like things become a class and actions become a method. Okay, another thing I learned, this was maybe we went a little deeper than this, than that other noun-verb thing. But I learned that queries are like questions that you're asking the object, and so they don't modify any of the state. It's just like, what's your name, that kind of thing. And then a command does modify, or might modify, and it could also call a modify, a command on another method, on another object. So here's some example questions. What is your name? What is your student ID? What classes are you registered for? Seems straightforward, right? Those should be queries. And then there's these actions which become commands in your design. So you have change your name to this, here's your new student ID, and register for that course. But again, lies. Those aren't very interesting questions. What is your name? Like, that's like the first 5 minutes of knowing someone, you're asking this kind of question. But what about these? Where do they fit in the query and command? What would it take for you to register this course? That's a question, but is it modifying something? Is it, it's not straightforward. I bet your schedule would be better if you added this. Is it? What do you think? That's a question. What was your schedule last year? That's a question. And then I know you haven't decided, but could you give me an example schedule? Like, what would your schedule look like? What even if you might not be able to register for those courses, what would it look like? These are questions, and they don't fit into this query command system very well. So we need a way to to ask these questions. These are hypotheticals or counterfactuals, that kind of thing. Like it's like another world, a multiple universe kind of thing. These are the interesting problems that we want to deal with. Okay, that's the end of that one. This one I learned was that you have a student that has some state, like a list or an array or some container of courses, and that is going to be references to course objects. The same with course.students, it's going to point to student objects, and you're going to have to keep them correlated so that if you ask the student what courses you're in, it's consistent with the course list. And then of course the university is going to have a list and the student, and they're all references, they're all pointers. There's my animation again. It's lies. There's just so many problems with pointers. First, you're pointing to a mutable object. Like, that's how we've designed it already. So you're already in this like deep water of dealing with things changing out from under you. They're ephemeral. Every time you boot up your system, you turn it on, like you've got different values for your pointers. Things get allocated in memory, like you're totally out of your control. And then what happens if you instantiate the same student object twice? Like, which could happen with like an active record situation or something like that. Which one, are you actually making the correct modifications? It just becomes a nightmare to keep it consistent. So, I mean, what I've learned over the years is just to model it with a value. Something that's not going to change, something that you don't care if there's 2 copies of them because you can compare them equal, and it has to represent the identity. Like, it doesn't matter when you boot it, where in memory it is. I'm going to point to someone. What is something that you could represent a student with? That you have control over, that is immutable, that is value? Ben?
I don't know, maybe like some kind of hash or something?
Okay. Other Ben?
Name?
Their name? Okay.
Ish.
Brian?
Object?
Object?
What do you mean?
Somebody else? Thank you.
Their face.
Like an ID?
An ID?
Yeah, like a GUID.
A GUID? Okay. Okay.
What about
Does the university already have a system for this?
Student ID?
Student ID.
And
Yeah. Student number, student ID. That's what I would use because the university already uses it. Everyone already knows it. It's on their ID, whatever. And then the course has a number as well. Yeah, question? No? Okay. And so that could be, it's immutable, right? Like a student ID is probably just like a string, which should be immutable.
A course ID is probably not the best thing because there's a new one every year, but it says the same ID.
Right, that's true. Maybe you should have the year in it.
It
Yeah.
also can do like SU16.
Yeah.
Right, right.
You have to have by semester like unique ID for each iteration of the course.
Mhm.
Instance of a course.
Sorry.
Yeah.
God, George.
Screwed it up.
Did I mention I'm also a database programmer? So continue.
Okay, so this is how you would set up like your little university simulation. You construct a university, construct a student, construct the course they want. Then you have to call register. You probably have to put these things into the university with whatever method. Call register method on student with the course, and then profit. It's a lie. So here's the question. Do we need to model all of that stuff? Is that the point of our system? Is to have a system that kind of mimics what's happening in the real world. Like people going to this piece of paper and writing it down, and then, is this what's important? So like, why is the register method on student? seems like the only reason was because we had that sentence in there that says a student registers for the course. And so then, further down with our design decisions, well, we need to record the course in there, right? So that's why the method is on there, because it's going to modify it. And so then why is the register method on course? Well, because we need to record the student in there, because what if someone says, what students are in you, right? Will they get out of sync? Maybe, probably, at some point they will, yes. Yes.
At some point in time, yes, because you can't call both of them at the same time.
Right. You have locks, and then it's a mess, right? And so then why are we even modeling courses and students? Like that's to me the real question. Why are we even talking about a thing that's called a student in our system? And I think the reason is object-oriented programming was made for simulations. It's really good at simulating stuff. So what should we model? What should we simulate? What are we building in this system? So here's the question for the group. If you had to use paper and pen, how would you model a registration system, a student course registration system?
Probably the same way that you saw at the university.
Mm-hmm.
You take a piece of paper and you say, this piece of paper represents the class, the course, this particular instance of the course for this term, and we're going to write in the names of the students who are taking it.
Mm-hmm.
Because to the university, ultimately, it's like then you would have a student.
And you don't have race conditions because two students can't actually write
At the same time?
But wait, going back to they didn't make writing your student IDs? Because okay, like...
Yeah, student ID. There was a
Okay,
student
yeah.
ID in your name. Yeah.
Okay.
Yeah.
It depends what you want to optimize for.
Okay. So we can explain.
So if you want to optimize for people registering for things, well, then, name, course ID. Sure, that's nice and easy. If you want to optimize for seeing who is registered for a particular course and making sure it doesn't overflow, then a separate sheet of paper for each course and put your ID on there, like you described earlier. So it depends on what questions you're going to be asking, and it's possible these are two different systems completely.
Or you have to do both.
So it seems like, there's three people who talked, and it seems like it's converged on this paper for a course, write your name down, that kind of thing. Does anyone have anything else? Any other suggestions? No?
And then you submit it somewhere and it goes and gets saved, right?
Yeah, and then someone takes it to a room and probably collates them and makes copies and like that kind of thing.
Probably what's going to happen is in order that someone would have to take all the lists and write for each student, have another piece of paper where they're writing out this student is taking course A at such and such time.
So
because like for example, the student's advisor will want to know what classes they signed up for.
Interesting. So I don't think they did that in France, just as a side note. I remember being like, well, what courses did I register for? And they're like, well, you don't remember? It was similar on the phone. You had to go to this little ATM style terminal and get your thing printed out. Anyway, these are all really good concerns, right? But you could think of how to solve it, right? Like, okay, someone has to copy and write new papers and stuff like that. So my question is, why don't we just do that? Why don't we just make a system where you can enter in a student ID and a course and a course ID, and that's your registration? Why are we making a thing called a student who's also a person, and then make a thing called a course that's, you just have two pieces of data that you're keeping in a many-to-many relationship?
Because people like to get cute.
They like to be cute. They like to model the universe.
It's like when it's like you're you're not designing the API. You're like thinking about like the data model and like all the questions you're asked, and like you're not thinking about like all the data model concerns get leaked into the API. So it's like, oh, we're gonna need this method to look this up, this method to look this
Right.
up. And it seems like if you designed it from an API first standpoint, you would maybe come up with a simpler way of looking at it.
Interesting. Or like use case first. Like, what do we have to do? Well, we need to have a place where we write everything down. Okay. And then use case, if you went too use casey, maybe you would even start writing, well, the student's advisor is a person, so we need a class called student advisor that can know the students that is advising, like, and it just gets messy. Lies. Okay, so everything I've said is like a lie, right? Like these have all been probably oversimplifications that the professor knew when they were telling me them, right? They're like straw men that I've been able to beat up on. Not saying object-oriented programming is better or worse. You can do all of this with object-oriented programming. And I think a lot of good programmers do. Like if you went to one of those like object-oriented design like gurus, they'd be like, what are people doing with all these classes? Right. So, like, for instance, I was just reading the refactoring book by Martin Fowler, and so many of them are about, like, blending this line or blurring the line between method and object, and like switching, oh, you need it, is too big? Well, now make a new object just for that one function. And it's not as clear as, like, noun verb, right? Queries are interesting. It was the lie. But simulation, which was the problem, was like these hypotheticals, these counterfactuals. Simulation, which is what object-oriented programming is all about, is actually great for counterfactuals. The biggest problem is it actually takes a lot of code and boilerplate to set up the simulation, to like create a new university, because you can't modify the one is real, right? You have to make a new one. And then you have to make sure that, if you're using active record, it's not actually saving it to the database and stuff like that. So it's great for that kind of thing, but it's rarely used because of all the boilerplate that has to go on. Value objects instead of pointers, they're better. Right, modeling all of the actors, you don't have to do that. It's easy. It's like, it seems like that's what it's for, what object-oriented programming is for. You just make a class and like, oh, now you can do an instance of it and like you're modeling actors. It's not what you're trying to do. And well, object-oriented programming is good for exploring different ways to model because you do have all these nice, classes and stuff. So you might explore, let's model like detailed stuff like a class hierarchy and stuff. And you say, let's model just this book, like a registry, right? And you can explore both because you got all the tools. Oh, and that's the end of my talk. Any questions? Thank you.
When you say actors, is that specifically for object-oriented design, or is that something that can be done in functional?
Oh, when I say actors, I meant the student who is registering is like an actor in this situation.
So they're it's the nouns?
Yeah, the nouns, the people, the processes that are going on. Yeah. You don't have to model the secretary separate
So was
from
that
the...
like an oblique reference to like the actor model?
No.
Okay.
No.
Just the idea of all the nouns.
Right.
Yeah.
Okay. Yeah, I don't know. It reminds me of the adage that education is a series of diminishing lies.
Interesting.
I read somewhere, heard about like one other value of object-oriented programming also became big when IDEs got big because of autocomplete.
Oh.
Well, that'd be.
Tail wags the
Maybe.
dog.
I mean, I would think more like static typing would be the thing with that, but I guess.
Right,
Most
because you know the
object-oriented.
type, the class of the thing you're typing.
You're talking Java.
Yeah, Java and C# kind of
Also,
thing.
like object-oriented programming is deceptively simple, I think, because it's like it's so easy to teach that class where you're like, write down your description, underline the nouns, underline the verbs,
Right.
turn them into classes, turn them into methods.
Because nobody ever sits people down and go, references are bad!
But I think that the industry tends to lean towards just things that are deceptively simple to
Right.
teach and ramp people up on. Because there are a lot of bad programmers out there, and
But
you got bodies, you got fill
But that's an asset.
Certainly
When you
know
were
this
saying
room.
it's a simulation, it's great for counterfactual. So if in my head, what you would say is, let's build the object-oriented version of this program, and then all the stuff that breaks, right? Write that down, and then build the functional version of it, right? So actually,
Is that what you think I was saying? I don't know.
it's kind of what when you said it would take too much time
Oh yeah.
and too many resources. And so when you're saying simulation, are you saying functional simulation, or you just mean like?
So like
because you're saying
in
it's great for a counterfactual. Well, a counterfactual in an object-oriented programming is a bug.
right.
That's,
So like if you imagine like what this like listen, I'm calling it a book, but you had a book where like this is the registry for classes, and there's a page for each class, and like you would go to an office and you say I want to be in this class, and they would write your student ID down on that page, right? So this is the database basically of classes. This thing has to have certain properties, right? And that's what you start modeling. What are the properties of this book that we want to capture in a computer system, right? That's the kind of modeling you want to do. And so if you can capture those properties, you can start to look and say, wow, we can simulate a world where the properties are different, or we can simulate a world where, say, what would happen if, like how many students could even, if we opened up a new course, a new English course, like basic English course that everyone's going to have to take anyway, how many schedules could be different, right? Or how many people might take that if they don't change anything else on their schedule? Like there's questions like that you would want to ask if you were like an administrator figuring out what courses to offer. And that's really hard in these object-oriented systems. It's really hard.
So that leads a little bit to like, I was thinking like would be a good way to design something like this. Because it ties a little bit to how what you were saying, like assuming that you actually wanted to create a good experience of registering people for the right thing. That's what you wanted to optimize for, and you were kind of circling around this with like the registration is the thing. So then the registration. There's your object, and it just says two IDs, like to course, student. To make it interesting, it'd be good to have like a preference, like the degree that you want that particular course.
This is something that, because I have a relational database background, that when relational database programming and object-oriented programming go hand in hand because everything is a table. So basically, the problem is every relationship becomes a table, and it can become very, you end up with all these tables and to express the relationships between two things. So, for example, a student registered in a class is the ID of the instance of the class, and then the ID of the student, and then creating tables for stuff like representing like rules, like the number of students who could be in a class, or requirements, this requires that, can become quite hellish in relational programming. Actually, the question I would ask, what I'd want to know is, how can functional programming help me overcome these lies? It's this background that from the School of Hard Knocks, where I've done all this work in object-oriented and relational databases. How can I use functional programming to overcome these problems and become a better programmer overall?
Well, I wouldn't say necessarily functional programming. Like, there's nothing wrong with objects and classes in and of themselves, right? They just, if you just go back to like just like an object or a class or something that holds state, like so you get rid of inheritance, so you just have this thing, right? And you can also get rid of mutable state. So now every time you change it, you have a new thing. You can also get rid of methods. Like, why do you need a method on an object? You just want to hold like some state or something.
With static methods or something.
But
and,
y'all are conflating something. Someone registering for a class doesn't mean they're registered for that class. That means they want to register for the class. A registration is a desire. It's an object. Yeah. So what do you store? You just store that registration.
It's a message that
and then you run it through a process and say, okay, here's everyone's registered.
Right.
Desired these classes. These are desired. Here's the outcome that is optimal for it. And that, notice how well that feeds into the functional aspect. That's input in, input, output.
Right.
Like any storage is incidental just because.
And it's just some strategy like first come, first serve.
And you want to run a simulation? Sure. Try that, input in, output.
Right.
Output becomes.
Right, you just generate thousands of registrations just randomly. And then you see what happens. Yeah.
But then you have, I don't know.
Well, that's where the simulation comes in, because before the students actually register for it, then you get to, address hypothetical problems like, requirements. I mean,
Can people actually graduate if there were 4 years like this? Like that kind of thing.
Do we really want to let anybody just register for any class?
Right.
Should we prioritize certain classes that everyone needs to take over elective classes?
Right. Or, does a certain class fill up like every simulation? Maybe we should have 2.
I just think of like the art department at UCF, where that was how it basically worked. Was they told you until they were blue in the face that you would have, there were only so many seats, but when the day showed up, all right, who needs overrides?
I think it's a great combination of all the different pieces of state that we're talking about, and then like the CQRS being sort of like if you don't do it this way, you're going to be in so much pain.
Yeah.
Because you have so much side effects that every time you try to register for a class, 3 other things happen.
Right.
If you're just looking to register for it, you don't want to like side effect something else.
Right. I mean, so it is a great point. Like the command thing, I kind of glossed over this. The thing is, there are commands that are more commandy than others, right? Like there are commands that write to the database, which is like a huge deal, versus there are commands that change a pointer or something, right? And those things, you might say, well, in this simulation, in this OO simulation, we're allowed to call each other's commands, but we don't want to save anything out to the database.
I think,
right?
If you've ever seen like Sandy Metz talks, she talks about like commands and queries and stuff. She's like a Ruby person, and like she's like very much into OO. But one of the things she talked about with like testing is like there's kind of a third class of methods that. So like a command would basically just be something that's like, I'm telling this object to change something about its state. And then the third class would be something that actually
sent an email or fired a missile.
And possibly mutate state of something else. And what the reason that she was bringing it up is just like in terms of testing, all you need to do is test that thing is, if you're trying to test the interface, you just need to test that thing sent that message.
Oh, it sent the right message.
You don't actually need to test any of it.
That's why you have so many layers. You have to have your persistence layer and your DAL and your actual interface layer. And it's like if you don't keep all those separations of objects, you're going to have chaos when you actually try to do something that you don't expect originally. If your model doesn't match perfectly, it's like, oh, I want to try to register for this just to see if I can hold my spot for my friend and then unregister for it. Well, it turns out they only do that once a day, and now you're locked into it.
Right.
You can only register for it once. It's like lots of hypotheticals are really hard to model if you don't think of it up front.
I'm going to take a little bit umbrage of this bad-mouthing of CQRS that's going on here.
CQRS is super important, right?
But I mean, like, because, you're saying, like, okay, some commands are more commandy. Well, kind of. I mean, like, look, it's
a fault I have of Haskell, too, where they just classify everything as I/O, right?
But Yeah, but here's the thing, like, you know, even the example you gave, but really there you're complaining about an optimization that might be taken, when like the real way that the system would actually evolve is you're just saving the commands and doing event sourcing, and yeah, something might write to a database at some point, but that's just, you know, an optimization, so you don't have to recreate event sourcing state from the beginning. But in theory, you can.
But you're agreeing with me, like that there are commands that you have said these are safe to call, and there are commands that like you can't just call all the time.
Well, they need to be validated against, but any
Like-
command could be rejected.
Right, but what I'm saying is there are commands that will fire a missile, right? And there are commands that change a pointer. Yeah, and like that's the
There's
thing.
no, like,
is-
warning
right,
there.
right. I mean, you don't even know if a query won't fire a
Yeah.
missile. Like that's the,
Oftentimes they do when you actually open up the database. You're like, wait, I thought it was just
right.
asking
What
for something.
what would happen if I fired this missile? Oh, let me see.
All right.
Yeah. Okay. Thank you. Any more questions? Yay! Cool. Thanks a lot. This was fun.
Which one would be possible?
All I
to,
can see is like the missile streaking away and somebody going, red, phone,
Eric, I stopped the recording.
Thank you.
I just found like in C# there's situations where just viewing something into the designer will run code.
Wait, what?
Yeah. Yeah.